e to the x equals 4 minus x squared. And this is 15 on 342. I mentioned two potential problems. So let's talk about the two potential problems before we start any example. Here's one potential problem. Remember, we start with x0, something we decide. We choose where to start. What kind of problem I could run into? I could, exactly. I could choose an x0 that makes f prime 0, and I will never get the solution. So make sure that f prime of x0 that we pick is never 0. That is one potential problem, because I will never get to x2. I will not even be able to determine x1 if this is the case.
You can't use an extreme value of the function.
So, no, I can't. And that's another problem. That's exactly what I was going to get to. That's a second potential problem. So if the function, let's say, looks like this, and I want to determine this solution, and there is between the solution I try to determine, or between the x0 that I choose, and the starting point, if there is a max or a min, the method will never converge. So the whole thing will happen in one spot. It will never get to the other. So it cannot be a max min between the starting point and the solution. That's rare, but it could happen. You will know immediately that that's the case, because the solutions will be all over the place instead of progressively getting closer and closer to a number. Okay? Good. So coming back here, like before, our first step has to be creating the function. So it's e to the x plus x squared minus 4 equals 0, and this is our function. E to the x plus x squared minus 4. And we have to find the x-intercepts, just one. So in the checklist, if the problem is asking you to find all possible solutions, I don't care for all. Just remember, I only want one. Because if you show me that you know how to determine one, I'm fine. Okay, just one solution. So here we are given a function. We have a function. We know it's continuous, no doubt. E to the x continuous everywhere, x squared continuous everywhere, negative 4 continuous everywhere. So I will say number 1, f continuous on all real numbers. Number 2, I have to find an interval. The interval is not given to us. So I have to put this function in the graphing calculator and give it some numbers. So in y equals, clear. So it's e to the x plus x squared and minus 4. So I keep forgetting if it's, okay, this one stays. In this building, they trust us. In other buildings, they remove everything. Okay, so let's say negative 2 is positive, negative 1 is negative. I'm done. I don't care to select anything else. I know there is a solution between negative 2 and negative 1 because a function is continuous and it changes sign from positive to negative. So I will write f of negative 2 positive, f of negative 1 negative. I don't care for the numbers. I just show this. And then I will say then by IVT there exists C, or in this case, with by R, it doesn't matter. You can use C. It's really not important. In the open interval negative 2 negative 1, such that f of C is 0. And now we are empowered with a method that allows us to determine that solution. Now I would like you to tell me how many digits of accuracy you want. 4, 5, 6. Let's say 5. How many?
3.
Okay, now let's say 5 digits. So we are going to look at 6 digits accuracy. I know you trust calculus more than 2 and 3. Okay, ready? I have to determine f prime, which is e to the x plus 2x. And number 5, I have to choose x0. Choose whatever you want, either -2 or -1. It doesn't matter. Okay, we want to choose -2. And in step 6, we want to create a function that is the Newton's method. It's Newton's method that I could put in the graphing calculator. I'm going to call it the way you wanted me to call it. How do you want to call this function? Let's give it a name. Doesn't matter. This is f, and this one will be...
UN.
Which one?
UN.
Okay, let's say g of x. The function is x minus e to the x plus x squared minus 4 divided by e to the x plus 2x. Let me show you how I came up with this. X minus the function over its derivative. This is Newton's method. This is what we are going to put in the graphing calculator. So let's go back to y equals. And let's put in x minus parentheses for the top. Don't forget parentheses for the top. Close the parenthesis. Divided by another parenthesis, e to the x, and plus 2x. Then close the parenthesis. So what we put in now, what we have now in the graphing calculator is Newton's method. Now, second and quit. Go back to variables, right here, this key variables. Go to the right, y variables. Select function. Function 1. What do I plug in it? You decided. -2. And press enter. Can anyone tell us what this number represents? Exactly. This is x1, indeed. Please copy 6 digits. -1.964981. Please watch what we do next. We copy what we had and overwrite -1 by the previous answer. Delete anything else. So now in function y1, I plug in that number. When I hit enter, what do I get? x2. Exactly. Closer number to the true solution, to r. But this is my x2, -1.964635. Do I have 6 digits? Yes. 964635. Okay. Now I repeat. At this point in time, I only copy. I don't have to do anything else. We will automatically replace the previous answer by what I had in x2. Okay, what is this? Good. Now let's see if we need it. 1, 2, 3, 4, 5. I don't need it. I don't need this. The method converged in 2 steps. And this is the answer. Because we decided to have only 5 digits accuracy. And you can solve in this way any equation you can think of. Okay, let's summarize what we did. We were given an equation that no one can solve algebraically. No one can solve this equation algebraically. There is no method. Then we created the function. And we said, okay, solving this equation means solving this one. Same thing. Solving this one means finding the x-intercepts of this function. We denoted the function by f of x. We know it's continuous as a sum of continuous functions. We found an interval in which this function, this continuous function, changes sign. And then we said by IVT there must be a solution between -2 and -1. Fine. We decided 5 digits accuracy. We determined the first derivative, and we had a starting point, either at -2 or at -1. Then we created a function just for the sake of the argument, in the sense that I have to put in the graphing calculator. This is the function I have to put in the graphing calculator. So once I replace x by x0 and calculate, I get x1. Then I plug in x1 in this function to get x2. Since we decided it's 5 digits, once they repeated in the next line, in x3, 5 digits repeated, I don't need to copy the third one. So I found the solution of this equation. It's an approximation, of course. It's an irrational number. But it's the approximation that we decided that we can live with for 5 digits. And that's it. Ready for another? Okay. Yes? Yes? Sorry about that. Okay, let's choose one and work on it for a couple of minutes, and then we'll work on it together. Is that okay? Is it a big deal? Not really. Just make sure that we do not pick x0. That makes f prime 0, because we will not even get to x1. We will not be able to calculate it if the denominator is 0. Okay. What about 17, which is 3 cosine x equals x plus 1. Again, no one can solve this equation algebraically. Make sure that your calculators are in radians, please. So start by creating the function, stating that it's continuous, find an interval, let me know if I can help, if you need any help. And I will put my function in too. 3 cosine x minus x minus. And then I would like to go back to more optimization problems. Do we need more time? Okay. Should we work on this together? One more minute.
I was just going to ask how you do that. Why one,
In variables and go to function. Yes. So in variables, go to function, and you choose the one and put parentheses for the number you want.
Did you copy what I want?
You don't have to because you just put second and answer. So this is, you don't have to copy because you may copy, you will only copy what you see, you will not copy the whole number. So let's start from the beginning. So you had in variables, you went to v, right, function, you chose the function, and you chose the starting point. What was the starting point? Okay, perfect. And then you go to second and copy this, but you override it by copying the previous answer.
Oh,
And you would copy all this, including what you cannot see. And then you press enter. And then you go again with second and now you don't have to do anything.
sorry, enter.
Yep. That's it.
And
You don't have to do anything.
Oh, 'cause
You
it
will
has
copy the previous answer.
Okay.
And something is wrong because it's going all over the place.
Yeah.
So we have, something needs to be adjusted, either the function or maybe the derivative or something.
Okay.
Or maybe your calculator is not in radians. Is that it?
Nope, or that was.
That was it? Okay. Yeah, be careful, because if you get something like 1 and then 15 and then -5 and then 13, something must be wrong. The method is so good it converges in 3 or 4 iterations at the most.
Okay.
If you're all over the place, something must be wrong. Okay, ready? Okay, so let's take a look. Okay, so we agree that this is the function 3 cosine x minus 1. I copied it correctly, I'm assuming. I'm on a totally different page. And the derivative is -3 sine x minus 1. Agreed? Okay, so the function is continuous. Did we find an interval? Or do I have to find it? Okay, let's find an interval. I put my function in, 3 cosine x minus 1. And now I'm going to go to second and table. Make sure Yes, radians. Okay, so I already see the calculator already gave me a solution between -2 and -1. You can choose anything else you want, but I'm going to choose -2, -1. So f of -2 is negative, and f of -1 is positive. By IVT, now if there is more than one solution, I will find one solution, you will find a different one. So that's possible too. That's fine. I will find one, you'll find the other. You want me to choose a different interval so we can check, or is this interval okay?
Was there one in between 1 and 2?
Possible. I didn't even look. Very possible. So I'm going to plug in 1 and 2. At 1, no. Okay, so between -2 and -1, which one would you like starting point to be?
2.
-2. Next question, how many digits? Accuracy. 6. Good, so we have to copy 7 digits till 6 repeat themselves. Okay, so x1 will be, I create g of x as x minus 3 cosine x minus x minus 1 over -3 sine x minus 1. There is no problem with -2. This will never be 0. I'm safe. I just have a problem with too many negatives, so I'm going to factor out -1 and change this. So this is x plus 3 cosine x. You don't have to. You don't have to. The answer will be the same. I just had too many negatives in there. So now I go back to y equals, and I put in my Newton's method. So from the beginning, x plus, don't forget parentheses around the top. If you forget parentheses around the function, you will not get the correct answer. So make sure you have parentheses around the numerator. Now divide, parentheses again, and the denominator is 3 sine x plus 1. 3 sine x plus 1. Don't forget to close the parenthesis for the denominator. So now I go to second and quit, and I want to copy function 1, and we decided to plug in -2, and I hit enter. This is my x1. x1 is -1.8562175. 2467, yes. Okay. Then, with second and entry, I override -1 and ask for the previous answer to be inserted. I click enter, and I get x2, which is -1.862356. 246862353. At this point, I don't have to do anything, just copy second and entry and press enter. And this is my x3, -1.8623649. I don't replace anything, I just copy the previous entry. And there is no need to copy this one. Why? I have 1, 2, 3, 4, 5, 6 digits that are the same. So there is no need for the last one. I already know the answer. We decided 6 digits, and this is the answer with 6 digits. The method converged in 3 steps for the accuracy that we wanted. Now, if we want 18 digits accuracy, it will probably take longer, right? Not just 3 steps. Do we understand this? Do we understand how it works with the calculator so we can get the numbers? Yes, everyone? Anyone needs help? Okay, so I think we should go back now to review. So this is the end of what we need for test 3. There is nothing else new that I'm going to add here. So moving forward, what I would like to practice. So let's go back and practice with 43 on page 333. Back to optimization. So let's take a look. If a resistor of R ohms is connected across a battery of E volts with internal resistance R ohms, then the power in watts in the external resistor is this, and I have to copy the power. It's nice that we are given the function. P equals E squared R divided by R plus R squared. I see 1, 2, 3, 4 different variables. They have to tell us something now. The way, right? So P equals E squared R. Uppercase R and lowercase r are not the same. Okay, it says now if E and R are fixed, but R varies. So this is fixed and lowercase r fixed. In other words, E and R are constants. That's what it means. So R is the variable. What is the maximum value of the power? So I could write that P is a function of R. E squared R over R plus R squared. And the question is, what is the maximum value of the power?
P prime of R.
Exactly. That's exactly what we need to do. P prime of R. Please remember, constants, if they are factors, have to stay outside. Do not mess with them. So this is a constant and is a factor. Do not worry about it. Leave it outside. The top function prime. 1. So then R plus R squared minus the top times the denominator prime over the denominator squared. So what is the denominator prime?
It would just be
2
R plus R.
R plus R indeed times the inner function prime, which is 1. Very good. Awesome. Very good. What do you think we have to do next? Because we have a lot of, I shouldn't say a lot, but we have prep to do here. And no, please don't say distribute. I know you're not going to say that. It's the key word. What is the key word here? Thank you very much. E squared is outside, and what do I factor from these two terms? What is common to these two terms?
R plus R.
Exactly. Perfect. What is left inside from the very first term?
R plus R.
Awesome. Minus?
Minus 2R.
Correct. Very good. Is this clear? Of course, I'm going to do this. And then the next step would be E squared, and in parentheses, what do I have?
R plus.
So the little r, and then minus r. Of course, I prefer minus outside, E squared and R minus R, because I want everything in descending order and I don't want negative leading coefficients. Okay, we determined P prime of R and we simplified as much as we could. There's nothing else I can do here. Now what? No, they say find the maximum power. I found the derivative of the power, and now I have to determine if the function has critical numbers. Good. R plus R cannot be 0. And even if R plus R, the function will not be defined when the denominator is 0 anyway, so there is no way that this is going to be undefined. So the only possibility is that P prime of R is 0, and that is, after we worked on this and simplified it to the core, we can say right away what the solution is.
R divided by E. Or sorry.
This cannot be 0, this cannot be 0. When is a fraction 0? Only when
E squared R, or when R equals E squared times
this is a constant. That's why I don't even care about it.
R minus R equals 0.
Correct. R minus R equals 0, which means R must equal R. I don't know if this creates a maximum. So I have R, a little r, and P prime of R. I have to study the sign left and right of R. Okay, so I would like to check with R divided by 2. Is R divided by 2 the left of R? If R is 5, this is 2.5. If R is 10, this is 5. And I also want to check with 10R. Is 10R bigger than R? Good. So which one you want to check first? With R over 2. So if this is R divided by 2, it's like 50 cents minus $1. So it's negative, right? So this will be negative with minus in front, and positive, and definitely positive. I don't even care about these. So 0.5R minus R with minus in front, sign. That's it. And now I'm going to replace R by 10R. 10R minus R with minus in front. This is typical for a maximum, and I have no reason to doubt that when uppercase R is lowercase r, the power will be maximum. Okay. You want to go back to graphing of a function with all the steps? Would you like to go back to limits using L'Hopital's rule? Would you like to go back to the mean value theorem and Rolle's theorem? Back to studying the function on closed interval?
Can we do another one like
Yes?
I think the second one would be today, number 15 on 332.
15 on 332.
It was when you find the max value.
Yes. Very good. Very good. Here's another. Right here on the top. 14. A box with a square base and open top must have a volume of 32,000 cubic centimeters. Find the dimensions of the box that minimize the amount of material used. A box with a square base and open top, so the same idea. Must have a volume of 32,000 cubic centimeters. Find the dimensions of the box that minimize the amount of material used. Is that what you had in mind? Perfect. So let's picture. So this is 14 on 332. So here's again our box. X, 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 H. They are telling us something that is 32,000 cubic centimeters. Obviously, we're told this is definitely a volume. I was hoping you will tell me, but it says it. Find the dimensions of the box, which means find x and h, such that that will have that will minimize the amount of material used. Yes, so now the question is asking us to find minimum surface area. Perfect. Again, we have to identify the volume formula, which we know is for the box.
X squared. X squared H.
Good. We know also the surface area for the box with an open top.
X squared plus 4x H.
Perfect. This time, we're not asked to minimize or maximize the volume. We're asked to minimize the surface. I do have a minor problem that the surface area has two variables in it, and I need to get rid of one of them. It will be difficult to get rid of x. No, I shouldn't say difficult. More work. And I know that this is 32,000. So from this equation, I will have to find h, which is 32,000 divided by x squared. And I will plug it in the surface. And now I will say, okay, the surface area is a function of one variable, s of x. So this is x squared plus 4x multiplied by 32,000 divided by x squared. I will simplify by an x, and the surface will be x squared plus 128,000 over x. Okay, I'm happy. I have the formula for the surface area. I'm asked to minimize it. What do I need to do? Very good. So then s prime of x will be 2x minus 128,000 divided by x squared. This is good, but I still need to have it in one fraction form and simplified. I need this prep for what follows, and why not do it now? So that will be 2x to the third minus 128,000 divided by x squared. And yes, I will move that 2 outside and have x cubed minus 6, 4, and 3 zeros over x squared. What next? Yes. No critical numbers from s prime being undefined. I know I repeat myself a lot, but just I need to refresh your memory that critical numbers come from two sources. But there is no point here. X cannot be 0. So x prime of x equals 0 means what?
X cubed minus 64,000 equals 0.
This has 3 solutions, but 2 will be imaginary, and we only need the real solution. Otherwise, we would have looked for 3 solutions. So x cubed equals 64,000. So x equals 40. Yeah. So 40, and this is in centimeters. So if the base is 40, I have to determine the height. There is no guarantee that this gives us the minimum yet. We haven't checked. So we have 32,000 divided by 1,600. So is it 20? The height? Okay, so next I have to show that this is indeed 40. Indeed gives a minimum. I will study the derivative, the sign of the derivative. Not this. I'm not going to waste my time with this. So let's plug in 0. If I plug in 0, which I can't really, let's plug in 1 because I don't want to confuse you with the denominator. Let's plug in 1. X is 1. What is the sign of the derivative when x is 1? Right here. Let's plug in 100. 100 to the third has 6 zeros, which is definitely going to be bigger than this, right? So this is typical for a minimum. Now, if I'm asked to find the surface area that is the minimum, I can very easily. I will plug in 40 squared plus 4 times 40 and times 20 to find the area that is the minimum. Any questions? Any questions? I know we have like 3 minutes left. If you would you like to quickly choose a L'Hopital's rule, a limit? Okay. An easy one, although there is nothing easy here. Okay, a very easy one. Okay, 18 on page 308. Limit as x approaches infinity from x plus x squared divided by 1 minus 2x squared. What type of rational function is this? Type 1, 2, or 3? Same degree of a same degree, right? So what is the leading coefficient of the top? 1. What is the leading coefficient of the bottom? So what will be the answer for sure? Negative 1/2. Let's do it with L'Hopital's rule. The top goes to, the bottom goes to, the sign is not important. So since it's a limit, since it's a ratio, I'm allowed, and since the answer is infinity over infinity, I'm allowed to use L'Hopital's rule. So then limit as x approaches infinity. The top prime is 1 plus 2x. The bottom prime is? Very good. It's still infinity over infinity. So now limit as x approaches infinity. We differentiate the top. We differentiate the bottom. So the answer is, as expected, negative 1/2. So it's useful to remember those three types. With the third one, you cannot, really do much. You have to determine where it's going, positive infinity or negative infinity. But the first one is always the leading coefficient over the leading coefficient when x approaches infinity. If it approaches something else, I don't know. And this type 2 is always 0.